Howdy, my name is Cole Jeffrey, and on behalf of my team Integrate X, I'd like to introduce you to our Nolanville Revitalization Project, focused on improving communication and as well as enhancing the overall walkability, mobility, and connectedness of the town. To reach these goals, our group, composed of several different interdisciplinary studies, including urban planning, landscape architecture, and computer science, have focused on creating a new sense of identity for Nolanville through the addition of a planned sidewalk network, improved green spaces, and a revitalized city center. We've also planned a 911 text campaign focused on improving the communication between the police department and the residents of Nolanville. And now I'd like to hand this presentation off to the rest of the group as they discuss in detail the specifics of our project.
So we'll start with the sidewalk network. What you see here is our proposed sidewalk concept for Nolanville. So in green, we have the existing sidewalks that have been built, and in red, we have our proposed sidewalks. You can kind of see around the town square area that we have that sidewalks have only been built on one side of the road, and we're proposing that we build them on both sides of the road. The blue highlighted areas throughout the map are our focal points, the main areas we wanted to get sidewalks to, and so those are going to be the Monarch Park, both of the elementary schools, and our proposed town square.
As an interdisciplinary team, we hope to offer creative thinking in our design solutions. We're analyzing the mobility demands for the area, and our revitalization plan emphasizes sustainability and the use of green infrastructure. In its current state, Nolanville has constrained sidewalk access. Through revitalizing the sidewalk network, we hope to improve connectivity and walkability within Nolanville, as well as providing streetscape and railroad area safety enhancements. Revitalization provides the opportunity to attract businesses, stakeholders, and investors to foster the creation of sustainable economic development for the area. Moving forward, we will use StoryMap to create a website with our full design proposals. And next, we'll discuss smart city landscape improvement.
The landscape design focuses on promoting connectivity within Nolanville. We anticipate for this to be done through appealing to small town feel while implementing smart city technologies into proposed landscapes, which are strategically placed to promote walkability and sociability, ultimately connecting people both to the city as well with each other.
To enhance the public space downtown, the vision is to create a lively plaza space at the corner of North Main Street and East Avenue I. A few key features for the plaza design include using permeable paving, local materials, and native planting, implementing interactive seating and water features, and proposing a smart kiosk and smart lighting features throughout. The redesigned space will help create a vibrant environment downtown where people can feel at home, whether during a peaceful morning or a lively evening.
The Market Street, proposed to occupy Avenue G, is designed to be a multi-use space that is designed to lay intentional groundwork for smart city technology implementation. This location was chosen mostly for its proximity and visibility to the highway, acting as sort of a poster child location for the town, showcasing its willingness to embrace smart city technologies and heightened social cultures with events. So the street design allows for normal use in everyday situations, acting as a home to electric vehicle charging locations, solar panels for generating electricity passively, and smart street lamps. In market day events, the widened sidewalks lead to tent placements for farmers market stalls, as well as solar panel shade structures that I mentioned earlier that can also be used for solar or for market stalls, basically creating a dual purpose for those items. Visibility to the highway will act as free advertising to passerbys, basically planting the seed for interest in the town and for anyone who sees that Market Street in use.
Smart Station, we will be focusing on solar panels, small businesses, and streetlights. On the top right-hand corner is a street image of East Avenue between north of 8th and 10th Street. The blue square, we will be implementing solar panels to be used as a charging station, as well as shade for vehicles. This property would be a good idea to design a food truck station or for even small businesses. Also, there will be a smart street lights implemented on this street, along with Main Street and the feeder of Highway 190. The street lights will be a sensor that can detect motion whenever there's movement. It would reduce 60% energy usage and the travel time would decrease by 25%. The sensor will be used to monitor and improve mobility, emission, as well as safety, along with providing streetlights.
Alrighty, and now we're gonna move on to the Text 911 campaign for our group. The reason that we are putting this together is because when we were speaking with our city representative, who is the chief of police, we were told that they wanted to encourage more people to use the Text 911 option that they've made available and have just the word get out about their ability to do that. And then below on this slide, you can see the potential Text 911 campaign ad that our group has created. This ad will be able to be posted onto the city website, and as well, we have designed it so that it is similar to the Call 911 campaign ad that's already published by the city on their website. That way there's uniformity, but also we change the colors up a little bit. That way there is a difference and people can note that you can text 911 versus calling. And then continuing on with that, as for the implementation of this ad, we'll be publishing it to the city website along with the Call 911 ad that's already present. And then we'll also be doing printouts for members that don't have access to the internet or just don't go on the internet as often at various locations around town. This will include elementary, middle school, and high schools, city hall, and gas stations that are frequently used locations around town. The outcome that our group hopes to have by creating this campaign is informing as many residents as possible that they are able to text 911 whenever they need. And then this way, individuals will feel more comfortable reporting any problems or occurrences, however big or small that they are.
Currently, Nolanville faces the problem of an understaffed police department. The national average for the number of civilians per single officer in 2018 was 335. For Nolanville, this number is 523, almost double. Additionally, they lack their own dispatch center for assigning officers, requiring neighboring Colleen's dispatch center to handle their calls. These factors increase the amount of time it takes for an officer to respond to a 911 call, and in an emergency, every second matters. However, we believe by using police response data from other cities, we can train a machine learning model to help predict the probability of incidents in certain areas of these cities as a proof of concept for Nolanville. We would then be able to see, given the location and the time of day, how likely it is an incident will occur in a given area. This model, once trained with data from Nolanville, will allow the police department to more efficiently assign officers to these areas during various patrol times, reducing the overall response time.
Our team is currently working with Nolanville's police department to find the required data for our machine learning model. Luckily, the city of Baltimore has already released a large dataset of police calls for service that spans several years, which can help us prove the viability of the model we propose. Baltimore has also divided up their city into smaller community areas that facilitate statistical analysis. Since Nolanville cannot be broken down into this many regions, our model will only focus on the northeastern communities of Baltimore, shown in the red box. In short, the idea consists of recognizing patterns in the time and location of incidents involving the police. For example, at 3 a.m. on a Friday night, an incident may be more likely to happen in the Northwood community area rather than in the Laurelville community area. Another hidden pattern may depend on the month of the year, for example, in December, during the holidays, where one specific region might experience more incidents than the rest. By inputting the hour of the day of the week, and the month, as well as the incident location into our model, we hope to be able to predict which region is most at risk. As mentioned before, this would allow officers to already be optimally spread throughout the community and always near where the next incident is most likely going to happen. Currently, our team is working on 2 different machine learning models. The first model is based on a set of logistical regressions, which basically learn the probability of an incident happening in a specific area at a specific time. Once we know the probability for each area, we can find out which region is most at risk at any given time. The second model is a neural network. This model can be used to predict the same things as a logistical regression. However, neural networks are known for their ability to find complex hidden patterns that other machine learning algorithms might miss. So our hope is that our neural network may find some of these hidden patterns in the data and provide better results than the logistical regression.
With the way things currently are, we are testing the viability and efficiency of our model on the publicly available data from Baltimore PD. Depending on the result of our test, we'll either modify our model or move on with translating the model and the data we get from Nolanville. However, data acquisition has been a bit difficult because we have been unable to acquire data from Nolanville that is compatible with our model. We are, however, working with the Nolanville PD to rectify this problem, and we're positive that we eventually would have a working model for Nolanville that will ensure analysis of data and approximate predictions with high accuracy. Thank you, and Gigam.